Hi again. Today we're going to talk about acid strength, and this will wrap things up for the week. Tomorrow there'll just be a short assignment. I like to keep your Fridays light. I like to keep my Fridays light too. Here we go. So, acids are classified as strong or weak. There are 6 strong acids. These first 3 are the only 3 you really need to know about, so you should recognize them as strong. They're hydrochloric, nitric, and sulfuric. There is a table of acids and bases that we're going to get to next week, and these are the ones at the top. The other 3 are perchloric, hydroiodic, and hydrobromic. I don't expect you're going to see them too often. Here's the deal with strong acids. Never forget. If you forget, you're going to get a lot of stuff wrong and get confused at different times. Strong acids ionize quantitatively. And that sounds super scientific. Here's what it means. You pop a strong acid into water, 100% of it becomes H3O. That's what makes a strong acid. So any one of these 6 in water just becomes H3O. The H just bonds with all the water, or all the H's bond with water. So for HCl, you're just left with this chloride, and all of it became H3O. 100%, no double arrows, quantitative reaction. That's what makes it a strong acid. All strong acids do this. Okay, I'm just stalling so you know how important it is. Strong acids ionize quantitatively. Do not forget. So that means whatever the strong acid concentration is, that's the H3O concentration. Every single time for strong acids, which are these. Okay? Move on. Weak acids don't ionize quantitatively, only partially, and most yield much less than 50% H3O, hydronium. So I'm going to show you what we can do with that. An example is acetic acid, which is vinegar, 0.1 moles per liter, actually only ionizes 1.3%. Okay, and that's its ionization equation. Double arrows, 1.3% yield. Okay, to calculate that percentage, we'll do an example very soon. You take the hydronium concentration, which you may be given, or maybe you're given pH, and this HX, this is just a general symbol for a weak acid. You've probably noticed that all acids have a hydrogen involved. Okay, so just hydrogen plus something else means weak acid. Okay, so the initial weak acid concentration is this term, multiplied by 100 to get a percentage. So let's do an example now. So I'm saying we've got a 0.2 mole per liter sample of any weak acid. We determine its pH to be 3.2, and we're going to figure out the percent ionization. Okay, I've written the formula there. Now I'm hoping it's not too much of a stretch to find H3O. This should be really, really simple. You should know exactly what to do right away. You get that from the pH. Right? So we do 10 to the power of negative pH. Don't forget the negative sign. Okay. Now we're pretty much done. We just have to divide by the weak acid concentration, which I gave right there. I forgot this times 100. I do that all the time. Okay, let's see. This is 0.32%. Okay, so be prepared for some really small ionizations. Really small percent ionizations. It's totally common. You're not going to see 80% ever. They tend to be strong, 100%, or really small like this.